Good morning, ladies and gentlemen. It's a special video forecast discussion for our first real accumulating snowfall of the season. It's December 9th, and it is absolutely beautiful out there, isn't it? We're starting to see a few snow flurries and snow showers starting to show up. I'm starting to actually see outside Freehold, New Jersey, as of 9 a.m., light snow starting to fall, and the grass is getting a little white out there. So I want to kind of walk through what's happening now, what to expect, and kind of basically, I guess, in a way, contain expectations and not contain it. The storm is evolving as expected, but remember, this is a light to moderate snowfall. It's not a blizzard. I know a lot of people were concerned about, oh, will I be able to travel anywhere? This is going to be a very, very wet snowfall, okay? And I'm going to walk through what we can expect, what will evolve, and what's happening in the atmosphere. And this video is going to be a mix of technical and also public that I normally do. That way it can answer all the questions, get everything out there. The storm's happening now, so I can pretty much share what I've been sharing for premium members. And then we'll have live coverage throughout the day, constant updates, and ho ho ho, you know. And I apologize for the background. My guinea pigs here are very, very excited about the snow. They have been jumping up and down. They've been doing their little hop all morning because they know something is going on when they peek out the window a bit. And just now, we actually starting to get a bit more of a steady light snow. So let's take a look at what's happening on the radar. I'm never really a big fan of these precipitation showing radar systems. They're a good tool, but you really don't want to rely on them 100%. And so you might be wondering, why is there green here? Does this mean it's going to be rain, snow, and it's not going to accumulate? Not exactly. What we're seeing here, it's really cool from the physics point of view, is that the snow has so much moisture in it that is being reflected as basically rain in some locations. So what this is telling me is that the snow ratios here we're going to be dealing with will be anywhere from 6 to 1 to 10 to 1, depending on the intensity of the snow band. Which is why when some people were asking, hey, I see an inch of QPF, that means 10 inches of snow. I'm like, nope, 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 because of the snow ratio. Now, this is also a very important factor here, that with the snow ratio being so low, that means that when the snow starts to fall, the last place it's likely to accumulate will be on any treated surfaces. Why? Well, let's take a look at the surface. As you can see at the surface, temperatures are pretty marginal. Now, this was expected, okay? In the forecast from the beginning, basically at the height of the storm, temperatures were expected to be somewhere around 31 to 33 degrees. Again, this is a very marginal environment for snowfall. Now, what that tends to do is lead to higher snowfall rates and also makes it a little bit more difficult for snow to accumulate. And that was the primary question at the start of this forecast when I was going about 2 to 5 inches and trying to work out what's going to be evolving here. The reason why I bumped it up a little bit to 4 to 6 inches along the coast here is that there is so much dry air at the mid levels of the atmosphere, around 925 millibars, that there's going to be a lot of what we call evaporational cooling. And that's why we're seeing the radar light up, but really not much really falling on the ground yet, because the atmosphere has to moisten up a bit. And that evaporational cooling leads to temperatures falling below freezing. And that is pretty much what we're seeing here with the wet bulb temperature. Okay, the wet bulb temperature is a temperature that you have to reach for to get steady precipitation. Okay, now in this environment, what we basically have set up here, and what we're basically seeing here in this air mass, is that it is going to get just cold enough. I usually cut off at about 33, 34 degrees to allow just for cold enough for snow accumulation. And as you can see here, once the precipitation really gets starting, the atmosphere will cool off rather nicely. Now what I'm watching here at the surface is the evolution of the coastal wave here. Currently we're about 1,004 millibars down here, okay? Now this is the Arctic shortwave. It's about 1,006 millibars. The circulation around the Arctic shortwave is a little bit better developed here. Now, what we're going to be watching for, and what's very important, is that this Arctic shortwave gives way to the coastal wave. And we know that's going to happen because of what's happening in the upper levels, which I'll show you in a moment. So notice the winds are coming in from New England, where it's much colder. You see right here, temperatures are in the 20s here, and dew points are around 3, 16. It's pretty cold and dry. So the source region here is coming in from a cold, dry place, and it's driving into the coastal plain. So this tells me that we have cold air available, but what we really want to see is this start to weaken this afternoon and evening to really allow more of that fresh cold air to come in. Currently, that is not happening over the Ohio River Valley. You can see the southerly winds, but you can see the separation with the Appalachian Mountains and that cold air streaming down from New England into our neck of the woods. Once again, high pressure over portions of New England playing a little bit of a role here. And we've been noticing that for the past couple of weeks. Hey, notice this theme that we keep on seeing in New England, where even very weak high pressure, and this is a signature of higher pressure here, is allowing colder air to stream down into the coastal plain. And we'll see how that evolves as we move on through the evening, allowing us to get to that 29, 30, 31 degree range at the height of this storm. And you can see on the surface map exactly what's evolving here. Here's your 1,004 millibar low trying to develop. Here's your higher pressure over New England, kind of building down, cold air damming its way down into the southern mid-Atlantic. And here is our Arctic shortwave coming on the way. At the mid-levels at 850 millibars, we could start to see the evolution start to take place with the colder air pressing down. And clearly what this shows is that at 850 millibars, more than cold enough to snow. What we're watching for is 925 millibars, where the gradient is getting very interesting because of all this dry air. Watch for temperatures around here to drop to -5, -6 degrees. And when that happens over the New Jersey coastal plain, Long Island, Connecticut, that is when we'll start to see the potential for convective snowfall, where you get these snow bands starting to develop. And we can see very clearly with the latest PVA being shown here is at 500 millibars, here's our Arctic shortwave, here's our subtropical shortwave, okay? And here's our waves of little disturbances that have been producing this wave of rain and snow over the southeast. Now watch what happens. This trough was a positive tilt, which is like this, okay? Here, let me draw a line here. I'll just draw this, okay. So a positive tilt is basically when I look at this, okay? That is what we talk about when we say positive tilt, and that's the way that this trough was aligned yesterday. Today, it's getting closer to a neutral tilt, okay? In fact, you can almost make a separation here where you have a neutral tilt here and a neutral tilt here. Okay, maybe a slight positive right there, okay? Now, what we're going to see as this shortwave interacts with this trough is that it ends up, and we'll change color here, that way we can differentiate, with a trough like this. Ever so slightly negative. This isn't a true full-on negative tilt. It's ever so slightly. So what this tells me is that as this Arctic shortwave dives into this base of the trough, it allows for stronger lifting aloft. It allows for the precipitation field to build back west just a little bit, and it allows for the whole storm to evolve. Again, this is not a pure major winter storm because we don't have the blocking in the northwestern Atlantic around 50 north, 50 west to slow this storm down and to do its kind of pivot that we normally see in major winter storms, but will be enough to allow the precipitation field to backfield, and as a result lead to some interesting weather for us this afternoon. And then let me get out of here. And so that takes me to the water vapor satellite picture. If I could just... So now you can clearly see on the water vapor satellite picture, I love using this satellite picture, everything kind of evolving here. Here's your shortwave diving south. Here is your moisture field driving north. Now what's going to happen is that as this dives into the Tennessee River Valley and then shifts towards the northern mid-Atlantic, watch for this to start to back towards the coast here just ever so slightly. And so what we're seeing here as a result is that this jet streak here is going to be very important. The jet streak at 250 millibars is going to basically shift more toward north-south orientation, allow for strong lifting over the northern mid-Atlantic, and as a result, what you'll see is a lot of blues and yellows starting to show up more and more as that lifting becomes intensified. And as a result, you start to see this whole precipitation shield fill in. Earlier this morning, people were freaking out because it was all scattered and broken. Now it's starting to fill in. It's starting to become more organized in nature, and you'll start to see a steadier band start to show up very nicely along the coastal plain and in some extent over eastern Pennsylvania. And then here you have your Arctic disturbance coming in to really basically mix up this party. So again, here is the general forecast that we're expecting here, okay? As you move to the west, like Scranton, Lancaster, really, this is going to not be an issue for you. A dusting to an inch of snow, no real big deal. As you move a little bit closer to the coast, like around Allentown, the northwest suburbs of Philadelphia, basically, up towards northeastern Pennsylvania, basically looking at 1 to 2 inches. Again, not a major storm, but it'll make it look nice. Then you move through the Philadelphia metro, southwestern New Jersey, northwestern New Jersey, the central Hudson River Valley, and northern Connecticut. I like 2 to 4 inches of snow here. Don't be surprised if a lot of this is on the low end of the forecast spectrum because of the wetness of this snow. But if you get into some of those higher bands, you'll definitely push towards that 4-inch total. And then here is your jackpot area, basically much of southern and central New Jersey, the New York City metro, Long Island, and Connecticut. You guys are going to be in ground zero of what I call prime lifting. You're going to have strong upper level support, PVA at 500 millibars, a negatively tilted trough this evening. You're going to have mesoscale banding support with colder air at 925 millibars, and you're closer to the moisture source. And so here, I could totally see where Philadelphia gets 2 inches, and then let's say right around Lakehurst, okay, they get 6. I could totally see that evolving here in this environment that this storm is developing. So you have basically at least 4 inches of snow here expected, possibly pushing up to 6 inches in some spots. And then there is a chance, because we're dealing with convective snow, that someone could see a 7 or 8 inch total. I think that'll be very rare, but I do think it is possible. So look for that snowfall again to become steady after 10 a.m., which is pretty much we're starting to fall on track on that. And then the heaviest snow I'm expecting from 2 p.m. today on through about midnight, and then we start to break off more scattered showers and snow showers and flurries as we head into tomorrow morning. And by daybreak tomorrow morning, skies will clear. The roads should be, cleared at the very least, but watch out for some black ice as we move on through this storm. Thank you for following NYNJPA Weather. We will have premium live coverage of this storm where you can ask me, hey, what's happening? What's evolving? Is anything changing? Throughout this afternoon and into the evening hours. And of course, I will have constant updates on Twitter and on the website itself. So let's get ready to rumble our first winter storm. And as always, stay safe out there.